Welcome to lesson 3.4. Today we're going to talk systems of equations in three variables. Only one vocab term today. We got an ordered triple, which is basically an ordered pair, but with three numbers instead of two, and we would write that as x, y, z. So here's where that z part comes in. Normally we've got our two variables, x and y, and we've got a normal coordinate plane, which is what we've been working with before. But if we look over here in three variables, we've got our x-axis right here, our y-axis here, and then our third axis is actually z, and that makes it more of a three-dimensional type thing. So not only do we have an x coordinate and a y coordinate, but we also have our z coordinate going above or below. So for each equation in three variables, it represents a plane. So when we're solving systems of linear equations, we're looking for where planes intersect each other. Now there's a few different options that we could have for solutions. We could have exactly one solution where all three planes intersect each other at a single point. We could have infinitely many solutions where the planes intersect in a line, or all three planes could be the exact same, so they're all sitting in the same spot. That could be infinitely many solutions as well. And the last one, no solutions, where no point, all three of them intersect at the same time. So if you notice this first one, we've got where two of them intersect in a few different spots, and the same one here, or all three planes could be parallel to each other and none of them intersect at all. So any of those are possible for no solution. Solving a system of equations in three variables is very time consuming. It's going to take a lot of paper. I'll give you that heads up right now. So basically what we do is we choose two equations and eliminate a variable using elimination. Usually we pick the easiest one to get rid of. And then after that, we choose a different pair of equations and eliminate that same variable. And what we do with those two steps is we create two equations and two variables, which we can then solve like we had been doing in 3.1. Then we've got our answer for two of the variables. We can go back to our original equations, pick one of them, plug in the two variables that we know, and solve for the last one. And then we can write our answer as an ordered triple. So we're going to start by looking at some one solution systems. Okay, so we've got this system right here. Picking a variable to get rid of, if you look at the y's here, it would be very easy to get rid of y, especially if we use this middle equation every time, because 1y I can easily make into 2y or 3y. So I'm going to use the middle equation in both the first two steps. I'm going to pair it with the first one and the last one, and I'm going to get rid of y. So what I'm going to do is I'm going to take these first two right here, and I'm going to multiply this second equation by 2 so that they get to be the same. So I've got 3x minus 2y plus 4z equals 35. I've also got negative 8x plus 2y minus 10z is equal to a negative 72. Okay, again, that's from taking that second one times 2. Now, you'll notice the signs are different, and when that happens, I need to add the equations together. So I've got 3 plus a negative 8x, that gets me a negative 5x. The y's go away. 4x plus a negative 10x is negative 6, z. 4z plus a negative 10z is negative 6z. And 35 plus a negative 72 is a negative 37. So here's one of my equations for later. So now I put these two together. And so again, to get my y's the same, I'm going to multiply that middle equation by 3 now. So now I'm going to have negative 12x plus 3y minus 15z is equal to a negative 108. And I'm going to keep that bottom one the same. 5x minus 3y plus 3z is equal to 31. Different signs again, so I'm going to add my equations together. Negative 12x plus 5x is a negative 7x. Z's go away. Negative 15z plus 3z is a negative 12z. And negative 108 plus 31 gives me a negative 77. So here's my second equation. So what I'm going to do now is I'm going to take those two and I'm going to pull them off to the side. Okay, and you'll notice that I've got two equations and two variables, so I'm going to solve it the same way that I did in 3.1. I picked the easier one to get rid of. It's going to be z, because I can make 6 into 12 very easily, and I can do that by multiplying this one by 2. So I get a negative 10x minus 12z is equal to a negative 74, and I keep that bottom one the same. Now you'll notice I have the same sign, so I have to subtract. Negative 10x minus a negative 7x turns into negative 10x plus 7x, giving me a negative 3x. Z's go away. Negative 74 minus a negative 77 turns into adding 77, which gives me a 3. Divide both sides by negative 3, and I get that x is a negative 1. So then I go back into one of my top equations up here, plug negative 1 in for x, and I solve for z. Negative 5 times negative 1 is positive 5. Subtract 5 to the other side. Divide both sides by negative 6, and I get that z is equal to 7. So now I've got x is negative 1, z is 7. I can go back to one of my original equations and solve for y. I'm going to pick that middle one there. So I'm going to have negative 4 times negative 1 plus y minus 5 times 7. That's going to be equal to a negative 36. Negative 4 times negative 1 is 4. Negative 5 times 7 is negative 35. Combine my like terms. 4 minus 35 is negative 31. Add 31 to both sides, and I get that y is a negative 5. So now I can write my ordered triple: x, y, z. Negative 1, negative 5, 7. So as you can see, very time consuming, but nothing that we haven't done before. Okay, here's another example. Again, looking for the variable that would be easiest. Okay, anytime where one of the variables has a 1 with it, that's going to be the one you use. So we're going to get rid of z first, and I'm going to use that bottom one for both of the first two steps. So I'm going to match it with the first one and the second one. And so if I match it with the first one first, I'm going to multiply that equation by 5 to get it to have a 5z in it. So I'm going to have 2x plus 4y minus 5z is equal to 18. Multiplying this one by 5, I get a negative 25x plus 15y minus 5z is equal to a negative 85. Same sign means I need to subtract. So 2x minus a negative 25x is the same as adding, so I get 27x. 4y minus 15y is a negative 11y. 18 minus a negative 85 is the same thing as adding 85, which is going to give me a positive 103. So here's one of my equations for later. So now I'm going to do the same thing. I'm going to match it with the second one, but now I only need to multiply that bottom one by 2 to get the z's to be the same. So I keep the top one the same, negative 3x plus 5y plus 2z is equal to a negative 27. Bottom one times 2, negative 10x plus 6y minus 2z is equal to a negative 34. Signs are different, so I can add them together. Negative 3 plus a negative 10 gives me negative 13. 5 plus 6 gives me an 11. These cancel out. Negative 27 plus a negative 34 gives me a negative 61. So here are my two equations that I'm going to use. So I'm going to bring those off to the side. And now, as you'll notice, I already have the same number in front of y, so I don't need to multiply any of them. The signs are different, so I go ahead and add them together. 27 plus a negative 13 gives me 14x. Y's cancel out. 103 plus negative 61 gets me a 42. Divide both sides by 14, and I get that x is 3. Plugging that back into one of my original equations, I got negative 13 times 3 plus 11y is equal to a negative 61. Multiplying these together, I get a negative 39. Adding 39 to both sides, I get a negative 22. Divide both sides by 11, and I get that y is equal to a negative 2. So now I've got x and y solved for, so I can go back and choose one of my original equations and plug in 3 and negative 2, so I can have negative 5 times 3 plus 3 times negative 2 minus z is equal to a negative 17. Negative 5 times 3 is negative 15. 3 times negative 2 is negative 6. Combine my like terms, I get a negative 21 minus z is equal to a negative 17. Add 21 to both sides, and I get that negative z is equal to 4. divide both sides by a -1, and I get that z is -4. So then I can write my ordered triple x, y, z, 3, -2, -4. Go ahead and pause the video and solve this, and then hit play and see how you did. Go ahead and pause the video and check your work, and you should see that the answer is -6 to 8. Now we're going to take a look at what happens when there is no solution or infinitely many solutions. So taking a look at this one, obviously there's not an easy variable to get rid of, so you just got to go with whichever one you want to. For me, I'm looking at the y's here because I can make 4 and 10 get to 20, and I can do 10 and 15 get to 30. So that's what I'm going to do here. I'm going to get rid of y's first. We'll take these two first. We'll multiply the top by 5. We'll multiply the bottom by 2, giving us 25x plus 20y minus 25z is equal to a -50. Multiplying the bottom one by 2, a -8x minus 20y minus 16z is equal to a -32. Signs are different, so I can go ahead and add these two together. 25 plus a -8 gives me 17x. Y's go away. -25 plus a -16 gives me a -41z. -50 plus a -32 gives me a -82. So here's one of my equations. For the next one, I'll pair these two together. I'll multiply that middle one by 3 and the bottom one by 2, giving me -12x minus 30y minus 24z is equal to a -48. Bottom one, I get 12x plus 30y plus 24z is equal to 48. Signs are different, so I can go ahead and add the two equations together. And this goes away, this goes away. I get, and that goes away, and that goes away, and I get 0 is equal to 0. This right here, if you ever see that, 0 equals 0, or any number equals itself, you should know that you have infinitely many solutions. Another example here, looking at it, that's supposed to be an equal sign. Hey, you'll notice that z is probably the one we're going to go with because I have that one z there. So when I put these together, and I'm going to multiply this top one by 3, so I get a -12x minus 6y minus 3z is equal to a 45. Whoops, that's not 45. And 12x plus 6y plus 3z is equal to 45. Okay, the z's, they're different, so I'm going to go ahead and add these together. X's go away, y's go away, z's go away, so I've got nothing over here. 45 plus 45 gives me 90. So when we have this right here, two numbers that aren't the same equal to each other, we would know that we have no solution. Go ahead and pause the video, do this one on your own, and then hit play and see how you did. So for this one, we should have gotten infinitely many solutions. You'll notice that we got past the first couple of steps and got to the two equations in two variables before we got our 0 equals 0. So it could be in one of these two, or it could be here. But anytime we see something like this, it's infinitely many solutions. And if we get two numbers that are different that are equal anywhere, we have no solution.